Let us solve this question. So, minus d by dt A is equal to K1 into concentration of A, that is number 1, and it becomes a rate law giving rate of disappearance of A according to path number 1. Similarly, we can write for other paths minus d by dt A equal to K2 into concentration of A into concentration of B, that is number 2, and minus 1 upon 2 d by dt A is equal to K3 into the square of the concentration of A, or we can write minus dA by dt equal to 2K3 into concentration of A square, that is number 3. Adding all these three rates, we get total rate equal to K1 into concentration of A plus K2 into concentration of A into concentration of B plus 2K3 into concentration of A square, and that becomes the answer of this question. Question number 4. The ionization constant of NH4 plus in water is 5.6 into 10 to the power minus 10 at 25 degrees Celsius. The rate constant for the reaction of NH4 plus and OH minus to form NH3 and H2O at 25 degrees Celsius is 3.4 into 10 to the power 10 liter mole inverse second inverse. Calculate the rate constant for proton transfer from H2O to NH3. The solution of this question is as follows. Since NH4 plus reversibly giving NH3 plus H plus, the equilibrium constant K is equal to 5.6 into 10 to the power minus 10, and H plus plus OH minus giving H2O. The equilibrium constant is 10 to the power plus 14, because we know Kw is 10 to the power minus 14. Adding these two reactions, we get NH4 plus plus OH minus with the rate constants K1 and K2 giving NH3 plus H2O, such that K total becomes 5.6 into 10 to the power 4. But we know that K total is equal to K1 upon K2. Therefore, K2 will be equal to 3.4 into 10 to the power 10, this is given, divided by 5.6 into 10 to the power 4. Solving this gives 6.07 into 10 to the power 5, and that becomes the answer of this question. Question number 5. For the gaseous reaction 2N2O5 giving 4NO2 plus O2 at 318 Kelvin, the initial concentration C0 of N2O5 was 2.48 molar, and after 200 minutes its concentration Ct was found to be 2.08 molar. Calculate average rate in terms of minutes, seconds and hours. Also calculate the rate of production of NO2 during this period. Let us solve this question. Since the given reaction is 2N2O5 changing into 4NO2 plus O2 Therefore, average rate is equal to 2.48 minus 2.08 over 200 minutes. So this comes out to be 2 into 10 to the power minus 3 molar per minute. This is further equal to 2 into 10 to the power minus 3 divided by 60. So this amounts to 3.33 into 10 to the power minus 5 molar per second. It's further equal to 2 into 10 to the power minus 3 into 60, that is 0.12 molar per hour. So these are the answers.